supposing that this is your 2 ohms, 3, 4, 5. Okay, this is 48 volts. Supposing that you are required to obtain your total resistance, total current, okay, the voltages, number 5 and number 4, power of each resistive element, and number 5, energy at the end of 10 seconds. Okay, this is only a direct substitution. Number 1, the formula for the total resistance, since this is connected in series, summation of Ri, wherein your I is equal to 1 up to n. So all you have to do is to obtain the sum of the resistances, 3 plus 4 plus 5 plus 2, and that is 14. 14 ba? 9, 12. Okay, number 2 is the total current by Ohm's law. Your I total is V total all over R total. So this is 48 all over 14. 48 all over 14. Tatlo, no? 3 point something. Number 3, what is B sub 1, B sub 2, B sub 3, and B sub 4? First is, we need to find your I total. Okay, what is our I total? 3.429 amperes. Okay, next is the voltage. So B1 is I1 times R1. The total current is also the same as your I1, parehas din sa I2, parehas din sa I3, parehas din sa I4. So this is just 3.429. This is also your B sub 5. Tama. Ayan. So this is 3.429 times 2. Ayan. B sub 2, 3.429 times 3. B sub 3, 3.429 times 4, and B sub 4, 3.429 times 5. Yan. So this is times 2, 58 volts, 10.287, $13.716, and the last is 17.145. If you will try to check the properties of series connections against this, all you have to do is to sum up your B sub 1 plus B sub 2 plus B sub 3 plus B sub 4 and see to it that it should be approximately equivalent to 48 volts. 6.858 plus 10.287 plus 13.716 plus 17.145. Approximately that is 48.006 volts. Okay? So kailangan natin rito yung total current 3.429 B sub 1 10 ko lang 6.858 B sub 2 10.287 B sub 3 13.716 and B sub 4 17.145. Tapos na to. Okay, we already have this one. Next is the power. So how do you find the power? Power, the basic definition of power is the product of the voltage multiplied by the current. So if you are looking for the power that is being dissipated by your 2 ohms, this is just the voltage across your 2 ohms and the current through your 2 ohms. Or simply, this is your B sub 1 is 6.858 volts times your current of 3.429. B sub 2 is the same, that is B sub 2 times I2, that is 6 or 10.287 times 3.429. The power in your 4 ohms, that is B sub 3, that is equivalent to B sub 3 times I3, that is B sub 3 is 13.716 times 3.429. B sub 4, 1, 2, 3, 4, that is B sub 4 times I4, that is 17.145 times 3.429. Okay, 6.858 times 3.429, 23.516 watts. 10.287 times 3.429, 35.274 watts. 13.716 times 3.429, 47.032, 17.145 times 3.429, that is 58.790 watts. Okay, so we are through with this. The next question is, how sure you are that this power are actually the consumption of your 2, 3, 4, and 5 ohm resistances? The easiest way to do that is to obtain the total power that is being supplied by your 48 volt source. The total power supplied by your source can be computed as the total current times your 48 volts. Total current is 3.429 times 48 volts. Total power that is being supplied by the source is 3.429 times 48, that is 164.592 watts. And be sure that 164.592 watts is also the sum of the powers consumed by your 2, 3, 4, and 5 ohm resistances. If you will try to add this, the result will be 164.612 watts. The difference in decimal places is just due to the rounding of figures. Okay? And the last requirement is the electrical energy at the end of 10 seconds. Electrical energy at the end of 10 seconds supplied by the source. Okay? So there are two approaches here that you can do. You try to individually compute for the energy consumed by your 2, 3, 4, and 5 ohms at the end of 10 seconds, or you make use of the total energy supplied by your 48 volts at the end of 10 seconds, whichever is more preferable on your part. So if you will do it at the 48 volts, energy supplied by the source is equivalent to the power supplied by the source times 10 seconds. What is the power supplied by the source? Power supplied by the source is just the voltage across the source times the total current of 3.429, and that is 164.592 watts. So if we will now try to compute for the energy supplied by the source, that will be 164.592 times 10 seconds. The energy will be times 10, 1645.92 joules. Or this is in terms of electrical quantities, this is 1645.92 watt second. Okay? If you have any questions with this, leave your message in our Google class, and I will address your questions and queries.